Hello and welcome to my workshop. Today I'm going to do an unboxing, but it's quite a special unboxing. I've ordered a new precision ground vise for my little mini mill. It's a very special type of vise. Now I'll show you a diagram of how it works and what it is and the company that I got it from. It's the supplier of SIG, actually, the main dealer in Australia, but they do deliver worldwide. Okay, so this is the SIG dealer in Australia, and they do supply worldwide. So it's called Aussie Tools. They're based in Melbourne. The guy to speak to is called Steve, if you want to contact him. All the details, and they're very approachable. You can ring them and email them. You can order online. So just to let you know, quite a few of you I think have watched me convert that little mill, and here it is here. It's the little SIG X2. And there it is. It's quite a versatile little mill. And if you want to convert a fairly useful mill to CNC, this is the one I would suggest you start with. They're reasonably priced, and the parts to convert it are reasonably priced too. So, on to today's subject. Oh, and incidentally, later on this year I will be converting a larger SIG mill. I haven't made my mind up whether it's going to be the SX3 or the SX4 yet, but that'll be later on this year. So what we're interested in for this video is work holding and vices. Now, here we go. This particular one here, which is an SDSG, vise, and it's a precision ground vise. So what it does, actually, the point of contact between the screw thread and the actual movable part of the vise is pivoted. Okay, so as you wind this screw and this jaw moves to clamp up, it not only is pulled down as well as towards the other vise, which keeps everything very, very square and accurate. And this is what I would recommend for vise. This is the 4-inch vise, or 100mm vise, which is 100mm or 4 inches wide jaw. But the jaws will actually open 122mm, which is nearly 5 inches this direction. These jaws here are removable, and you can actually put them on the back side and screw them onto here as well. So you can actually clamp quite a large object or large plate on the top section. So that's why I chose this one, and I'm going to mount it long ways on my bed. So I hope you understand a little bit about this now, and I'm just going to unpackage it and show you, and I'll check it out to see how accurate it is, and we'll put it on the mini mill, and we'll tram it all in, and I'll show you how to do that. Okay, so here we go. It's well packaged. There's a little brochure here that okay, just says what the accuracy, machining accuracy, and that's a nice thing to have, that it's been checked and warranty and what have you. So we've got something to check against. Oh, these are like the little dowels that you can put on the underside to lock it into the T-slots. And I think they'll fit straight into that mill with a bit of luck. Nice chromed handle. Let's see what it looks like inside. Oh, look at that. That is nice. It's fairly heavy. It's about around about 10 or 12 kilos, I think. I'll fetch you in for a closer look. Well, well packaged and well lubricated. Better get a rag, I think. Look at that. Very, very well machined. Very nice indeed. Very nice motion. There's very little backlash on it too. Jaws fit together. Actually, you can't actually feel the join at all. That's very good. And on the underside here, this is where these little doweling pieces go. There's a little burr there I'm going to have to file off, I think. But if you was fitting it crossways, obviously these doweling pieces would go here. But as we're going longitudinal, I'm going to fit one there and there. Well, that's the only thing I can find wrong with it. It's just a little tiny bit of burr there. But it'll probably be all right, but I will take that off. But, you know, for the price, I'm very pleased with that. Let's take some measurements on it. See how accurate it is. So this is a granite surface or granite top, which I'm just going to put some WD-40 on. Cans nearly coming to the end. Okay, why a granite surface? Well, it's accurately ground, totally flat, and granite doesn't particularly move very much. It doesn't expand and contract very much, so it remains perfectly flat, and you can measure off it. And what I mean by that, I'll show you. Now it's completely smooth. So what we're going to do is put a vise on here, just make sure it's totally clean on the bottom. There it is. Okay. I can tell just by sliding that on there, it's totally flat on the base. So I'm going to get a DTI gauge now and just take some measurements over this to see how true and accurate and parallel with this surface it is. So let's just see how parallel this is. Well, that's absolutely perfect. Do you know, I was not expecting that degree of accuracy, but there it is. It is beautiful. You cannot beat. You can't beat it for the price. I mean, I know a lot of people go and buy orange vices and makes like that, and pay nearly $1,000 for them. This, to my door, was less than $200, and I'm really pleased with it. Really pleased. In fact, so pleased I'm probably going to order a second one. That is really, really nice. I can't fault it. The action is beautiful. I mean, this is okay to use just to slacken it off and clamp it up, but I find it a bit tedious using this to wind and wind, so I find it's easier to wind with one of these. Much faster. I mean, the action is perfect. I'm really happy with the purchase of this. So I really would recommend this item to anyone. If you're in for buying an engineering vise for a milling machine, these are the people to go to. I can't fault it. So let's get it on the milling machine. Now I'll show you how to tram it in. Tramming in means accurately bolt it down onto the machine and line it up square with the spindle in relation to the table. So that's called tramming. Right, it's not exactly the way I wanted to put it on there. I think the first job I'm going to have to do actually with this, when I've got it all set up, which will be another video, is to make some toe clamps to fit this. I really want to have it long ways, but for the time being I'm going to set it up in this way so I can start to use it, and probably the first job I make, it will be toe clamps for it. But these are steel clamps that I have, and it's a little bit of a makeshift job, but I'll show you how to tram it in. In other words, make this back jaw here square with the running of the spindle. So, you know, to get it roughly there, use just an ordinary square actually, and these are just nipped very, very, you know, not very tight at all, so I can just knock this into Okay, that's a bit more there. Now, to get it absolutely square, what I'm going to do is I'm going to make my DTI gauge on this back pillar and run the gauge along the rear stationary jaw. Okay, what I'm going to do now is I'm going to put this in a rough position, but I'm going to take the y-axis all the way back to make sure that the vise is not going to crush anything back there, or indeed if I get the full travel. That's it, that's a full travel there. Okay, let's take it all the way forwards. I do recommend these to any of you as well. Okay. And I can see that the tool is about here. The center of the tool is about in line with the back of that, which is fine. So I've got sort of full travel there. I think it actually moved slightly. Okay. I'll just tighten it up a little bit more. Just ease it up, because what I want to do now is open the jaw and set the DTI gauge up so it's running on the stationary jaw at the back here. Okay, so you can see the setup I have here. It might sound as though I'm talking down a drain here a little bit, but I'm sure you'll cope with that. So what I'm going to do is zero this. To the best of my ability. Okay. Now, I've just done this with a square, and I just run it up. I surprised myself how close I got actually. But there we go. I'll just run the X. Okay, so that is each one revolution of this dial is 1 millimeter. So that's 0.1 of a millimeter. So I'm going to run it back the other direction. Ooh, the other direction. Okay, just going to bump it, just one end here, just to, ooh, might have been a little bit too much. There you go. I've got this one a little bit tighter than the back one here, so it'll just pivot around this a little bit. So let's run it back and see how true that is now. Let's set the 0 again. Oh, I think that's about right. Okay. A little bit too much. So let's set the 0 here. You haven't got to move it very much. There's a little bit of fiddling around. We'll take it halfway there. Let's see what that does. Oh, I think I can live with that. I mean, there is a slight variation, and that's the flex in this arm. Do you know, I'm going to tighten it down at that. Now, as I squeeze this down, tighten it down, you might see this gauge move a bit. A little bit that side. A little bit that side. A little bit more that side. Not that side. Okay. That's as tight as that needs to be. Let's just run it again. Oh, wrong way. Well, that's pretty well damn perfect. So now we have everything running parallel now with this fixed jaw. When you clamp a piece of material up in this vise, everything is clamped against this fixed jaw. And we have this fixed jaw now running perfectly parallel in relation to the spindle and the tool in the spindle here. So that is how you tram a vise into your table on a CNC or a manual milling machine. So there you are. That's how to tram a vise in on a CNC mill or indeed a manual mill. That's how it's done. So, you know, the more accurate that you can get your vise or your holding device, of course the more accurate and square your part is going to be. So I hope you've liked the video today, and please press like, subscribe to my channel, that's a good thing to do. And now there's 350 videos between my two channels, and I'll be back again with another video in about a week's time, I suppose. So thank you for joining me, and it's bye for now.